Today we're going to study chapter 4, an independent one. Why I say it an independent one? Because it doesn't relate it to the other chapters. In this chapter we're going to study reaction energy. Well, that means we're going to study a special branch of chemistry that deals with the energy. Reaction energy, as we can see in this picture, it's a combustion of natural gas, so energy released as heat or light. Okay. So what branch of chemistry is specified for this kind of phenomena? I mean releasing energy or absorbing energy during a chemical reaction and physical change. There's a special branch of chemistry called thermochemistry. What is thermochemistry? Thermochemistry is the study of transfer energy. Look, it's the study of transfer energy as heat. So either absorb it or release it, given up or taken in. It's the study of transfer energy as heat that accompany chemical reaction or physical change. So during any chemical reaction and physical change, chemical reaction, it means chemical change and physical change. There will be change in energy, transferring of energy. So thermochemistry is specified for that purpose. Very well. The amount of energy that transferred, either absorbed or released, it measured by a special device instrument called calorimeter. So from now on, there will be a common mistake by you during the final examination. You don't know how to make a differentiate between an instrument of measurement and unit of measurement. Okay? The device that used to measure the amount of energy transferred called calorimeter. It's totally different from the unit of measurement, which is kilojoule. Calorimeter, that means calorimeter is a device, it's a device used to measure the amount of energy absorbed or released as heat. Absorbed or released, it means transfer. And we have thermometer. Thermometer is another simple device, one of the most simplest instruments exist in laboratory called thermometer. It's used to measure the temperature. So now we have two close expressions together, temperature and heat. Temperature and heat. Maybe still now you may thought that they are same, but actually there's a huge difference between them. Heat, it's a form of energy. Heat is a form of energy, but temperature is the average kinetic energy. Kinetic energy, it relates to kinetic energy, but heat, it's energy. So they are totally different from each other. So now we have to make a differentiate between heat and energy. Then I'm going to draw a picture of calorimeter. It's very important for this year because I remember last year there was a question about some part of a picture in chapter 8, yeah, and most of the students, they didn't know because of it was mentioned only at the picture. It was not in a content, which was porous graphite. So calorimeter is very important for this year. I'm talking about the picture. Now I'm drawing the picture or photo of calorimeter. Well, so now what's the difference between heat and temperature? First of all, heat energy is measured by calorimeter, but temperature can be measured by thermometer. Look, heat by calorimeter, but temperature by thermometer. It's energy that transferred from highest temperature object to lowest temperature object. But temperature is measurement of average kinetic energy. Okay? It can be measured directly. I'm talking about heat energy. Cannot be measured directly, sorry. Heat energy, it's measured indirectly. It cannot be measured directly, but thermometer can be measured directly. Well, let's see what are the following points that I'm talking about just now. So here we have temperature, here we have energy. Okay, energy is a transfer. It can be transferred between samples from the highest temperature to lower temperature. Or it's a form of energy that transfers between samples due to their difference temperature degree. But temperature is a measure of the average kinetic energy. Look how they differ. Well, it cannot be measured directly, or it can be measured indirectly, but this one can be measured directly. I mean, if you want to measure temperature of anywhere, just put your thermometer in there, in that specified place. Immediately you're going to get a degree of Celsius or Kelvin. So that means the unit of measurement of temperature is Celsius or Kelvin, whatever. We have something more, but the most common used units are Celsius degree and Kelvin. But for the heat, which is a form of energy, it's measured by kilojoule, and can be changed to joule. You know the conversion factor. Okay, it's very easy. You have studied in previous grade. I'm talking about 11 or 10. Well, energy transferred as heat. Energy transferred as heat. So it talks about energy as heat is usually measured in units of what unit? Kilojoule. But look, if I change this energy transferred as heat, usually measured by which device? By which device? Calorimeter. But here, okay, it means by unit. So we have to say kilojoule, kilojoule, kilojoule. kg is abbreviation of Korean. Okay. Well, don't be sad, my dear students. Ktijuan also. Specific heat. A very important expression. Okay? It's a common guest in the final examination any year. Final examination without specific heat. This is no way. There will be this man always in the final examination. Specific heat. Okay? What is specific heat? Let me simplify the definition of specific heat. It's very simple. Look, suppose that we have 1 gram of sample, 1 gram. Look, it's sample, 1 gram of sample. We want to rise its temperature by 1 Celsius degree or 1 Kelvin. Rising temperature by rising temp by 1 Celsius or 1 Kelvin. Look, we have 1 gram of sample. We want to rise its temperature by 1 Kelvin or 1 Celsius degree. For that purpose, we need energy. We need energy. So we have to give it energy. So it's the amount of energy, CP, it's amount of energy that required to rise temperature by 1 Celsius degree or 1 Kelvin for 1 gram of sample. Or it's the amount of energy that required to rise temperature of 1 gram of sample by 1 Celsius degree or 1 Kelvin. Okay? So it's the amount of energy that required to rise the temperature of 1 gram of a substance or sample by 1 Celsius degree or 1 Kelvin. This is CP. So each individual component of CP is very important. Before starting to study CP, I just remember what is picture of calorimeter. How to draw a calorimeter. It's very important. Okay. Suppose that we have a sample dish here. You have to know if we want to make any reaction between some identified substances in the laboratory, we're going to need a container. Okay. We have a special apparatus. Some of them, for example, a sample dish. Okay, it's sample dish. This is sample dish. Sample dish. Dish, something like a glass. It's a container, a special container that the chemists, they make a reaction inside of it in the laboratory. It's made from graphite or something like silicate, like this. Okay. So for example, we have A plus B or whatever. We have a reaction here. Okay? Remember, we want to measure the amount of energy that release it or absorb it. So it's indirect measurable. Indirect. Why we call indirect? Look, we have a reaction in a sample dish, but we don't have a special device to put in this reaction to measure the amount of energy. Look again, I repeat. We don't have a special device to measure, to put into a chemicals to measure the amount of energy that transferred during this. So we have to transfer the amount of energy here to save substance such as water. That's why we will put here, we will put sample dish in a, for example, something called bomb, steel bomb, okay? Like this, steel bomb. It's called steel bomb. Why steel bomb? Because of inside of it there will be a reaction, steel bomb, okay? And then we will surround steel bomb by water. So here will be water. It's water. Water. Okay. This is aveta Z, water. Water. So we have a plan to transfer of energy of this reaction to water. Then we can measure the amount of energy from water safely, directly, easily. But we don't have a special device to measure the amount of energy directly. Then we have to put water into a box. I'm just going to mention the major parts of calorimeter. Remember, this is calorimeter. But this is an instrument, so any instrument in the laboratory contains starter bottom, starter point, okay? So here we have igniter wire. Igniter wire. Well, ignition wire, it means start bottom. If you put start, okay, immediately it will start to react, okay, then it will transfer its energy to water, then we can measure energy in water easily. So because of here we have water in each corner, so that's why we need a stirrer or homogenizer, something like a fan. It's stirrer, okay? Something like stirrer is to homogenizing the energy distribution in each part of the calorimeter. And here we have thermometer. Thermometer to measure the temperature. So before starting the reaction, we already measured the temperature initially. I mean T1 is measured. Suppose that T1 is 25. Okay, whatever. And then when the reaction takes place, okay, if reaction releases energy, T2, T final, will be greater than 25. Because it releases energy to water, water absorbs energy. It releases energy to water, then water absorbs energy, then we will find T final. But if it absorbs energy, Okay, water, it will absorb from water. Okay, so if it absorbs energy, that means T2, T final will be smaller than this number. Anyway, we can understand that we will calculate delta T. So which data can be calculated from the calorimeter experiment? Delta T change in temperature, in Kelvin or Celsius, whatever. So, but mister, you have told us that calorimeter is used to measure the energy, heat, not temperature. But now you say that, you just say in the final data that can be obtained from the calorimeter experiment is delta T. Change in temperature. But how we can measure energy? Look, don't be sad. Then we will introduce delta T in an equation formula. Look. Equation form. We can get the value of energy. That's why we have to say energy measured indirectly. Before we just measure delta T, then we use a delta T in an equation formula. After that, the final result will be energy, which is heat or Q, whatever, in kilojoule or joule. Okay? This is calorimeter picture. It's very important. I know that there are some missing part. There are some missing name of the parts, such as outer side of the shell, inner side of the shell. This is water. Okay, this is insulator. Well, whatever. I know that, but I just mentioned it. The major parts, which are thermometer, water, stirrer, sample dish, steel bomb, and ignition wire or igniter. So that was a calorimeter. And now, look, we can see delta T here. Where we get this value from calorimeter. Then what is this? This is energy, and this is amount of substance, and its property. It's a standard, it's a constant. So when we introduce each individual components of this equation form, we can get the value of energy like this. Look, delta T from calorimeter, mass or mole or amount of substance. Previously, we know how much amount that taken. Cp, it's a constant, just like my name. My name is м.Höger, my weight, I know my weight, okay? So that, just like this. Cp, it's a constant. It's a property. Well, it's nature. Specific heat. So we will talk about the purpose of specific heat, for what it uses. Well, Cp, it's very important formula. Please memorize this formula, just like your name. Cp is specific heat. Okay, specific heat at given pressure. It's very important at a given pressure, because Cp can be changed by changing the pressure. Q, it's energy lost or gained in joule or kilojoule. No problem. M, it's amount of a sample in gram or mole or in unit of volume also. I'll show you why in unit of volume. This is not mass, it's amount of substance. Delta T, difference between initial and final temperature in unit of Celsius or Kelvin. You know how to change temperature. It measures by Kelvin or Celsius. Changing Celsius to Kelvin plus 273, or Kelvin to Celsius minus 273. Just like this. It's very simple. I think you know this. Very good. And now let's talk about some critical things. Write down each of these things. It's very important. Cp, does not depend on Q, on M, on delta T. Cp does not depend on Q, on M, on delta T. Cannot be changed by changing M, delta T, Q. So Cp has no relation between, has no relation with, or it's better to say with. Please get back. Okay, just get back to the business. Well, Cp has no relation with what? With Q, M, delta T. But why they are appear in the formula of Cp? Well, Cp, it's a nature. This is nature, naturi, okay? It is naturi of substance, nature of substance. Okay. Cannot change by changing Q, M, delta T. So, what factor can influence Cp? Cp can be changed by pressure, type of substance, that means Cp for aluminum, okay, it's constant. If you change, T will not change, Q will not change Cp, M cannot change Cp. So how can Cp change? Cp for aluminum stay constant until you change the pressure. When you change the pressure, Cp will change. And if you change aluminum to iron or to copper or to sodium or to any other substance, Cp will be changed. So remember, Cp is a fingerprint. There are no two substances with the same value of Cp. So Cp is a fingerprint. There are no two substances with the same value of Cp. Cp for any substance is specified. Well, very good. Okay. So how many factors can influence Cp value, pressure, and if the substance change to other substance, there must be a new value of Cp. So there are a huge amount of units of Cp. Look, Cp, Q can be measured by joule and kilojoule. M, mole, gram. Delta T, Kelvin and Celsius. So, for example, for Q use joule, for M use gram, and for delta T use Kelvin. It's one unit. You can make another unit. Select this, this, and this. No problem. Another one. Select this, this, this. Another one. Select this, this, this. So you can make around 30 around. Okay, I didn't say exact 30 because I knew that there are more than 40 units. So these are different units of Cp, etc. There are more than 20, more than 30 units of Cp. Specific heat can be. So for what purpose we are using Cp? Look, another thing. Well, I'll get back to the previous page here. If we measure Q, amount of energy, Q equals to Cp times M times delta T. Remember, Cp doesn't depend on these components. But about Q depend on, amount of energy depend on Cp, nature, mass, amount of substance, mole, and delta T. Okay, so Q, there are three factors that can influence Q amount of energy. Cp, M, delta T. There are direct relationship between them. So as much as Cp increase, this is increase. Increasing M, it will be increased. Delta T, when increased, Q must be increased too. Okay? So for what CP use? CP use it to compare. CP use it to compare the tendency, the ability, the capacity of different substances to measuring, to absorbing energy. So if we have two substances, A and B, and they asked you which one absorbs more energy, you have to say the one that has greater CP. Okay? Which one absorbs more energy? The one with bigger value of CP. Remember, it was a question from last year. Okay, we have two substances, A and B. Which one absorbs more energy? The one the one that shows bigger CP. For example, CP here equals 2.2 and CP for this equals 2.3. Which one absorbs more energy? Of course, this one. That's why there are a direct relationship between these three parts of this equation with Q. Look, specific heat can be used to compare heat absorption capacity for different substances. Bigger CP, bigger amount of energy. Smaller CP, smaller amount of energy. Look, I'm talking for you. You must write this note. It's very important. Look, specific heat usually measures in. Well, we can, how you can solve this type of version? CP equals to Q over M times delta T. So joule, yeah, it's correct for Q. Mole for M, yeah, it's correct. Celsius for delta T, it's correct. This one, joule for Q, yes. Gram for M, yeah. Delta T, it's correct also. Joule for Q, gram for M, Kelvin for delta T, yeah. So all of them are units, different units of CP. The quantity of energy transfers as heat during a temperature change depends on I just explained it. CPM. Look, the nature of the material. Nature, it means CP. The mass or the amount. Okay, it's correct. If you see mole, also it's correct. The size of temperature change, it means delta T. So this is CP. It's M. It's delta T. So these are factors that influence value of Q. Okay. Let's solve mathematical problems about CP. But before that, before doing this, I have to watering my throat. Sorry. Well. Good. A nice question. Not an ice, a nice, well. 4 grams of sample. It's M. 4 grams of sample of a glass was heated from 274 Kelvin to 314 Kelvin, 340. These are delta T. Okay. A temperature increases by 40 Kelvin. This is delta T. Look. It's T1, it's T2. Look. It's not a rule always. The first T will be T1, the second T will be T2. You have to read. Heated, it means we are heating something, so T2 must be greater than T1. Delta T must be positive. So when we say heated, it means delta T, it's positive. But cooled, T1 greater than T2, so delta T will be negative. Here, T1, T2. And the amount that changed is 40. This is delta T. So, without this value, we can calculate. 340 minus 274 equals to 40. So you can just forget about this part, or you can just forget about this part. No problem. Okay? Each options Each one is possible to have. But now in this question we have both of them together. And was found to have absorbed 32 joules is Q. Look, when you read any question about CP, immediately, if you see M, delta T, and Q, don't wait for anything, don't complete to read the question, immediately calculate CP. Immediately, if you have M, delta T, and Q, immediately get the value of CP. Then you can use CP for the unknown. Very easy. Look, I'm not going to finish the question. I'm talking about reading. But because of we have these, all the parts of CP equation, that's why I have to get the value of CP. CP equals to Q over M delta T. We have Q, we have M, and we have delta T here. Or you can get value of delta T. Delta T equals to T final minus T initial. Delta T equals to 340 minus 274 equals to 40 Kelvin. So now CP will be, Q is 32 joule, and M we have 4 gram. Well, doesn't need to write units. 4 times delta T, it's 40. So CP equals to 0.2. Q, it's in unit of joule per gram times Kelvin. This is CP. Okay, mister, but I don't know why we did. Well, as I told you, just follow my recommendation. If you see M, delta T, and Q, immediately get the value of CP. Then you can use this value to the unknown. Look, what's the specific heat of this type of glass? It means CP. Okay, CP. Well, we have calculated CP. So without 0.1, without unknown of A, there's no option you can get this. Okay, even if it's unknown, even if question didn't request it to get the value of CP, you have to calculate. How much energy will the same sample of glass gain? Q, then energy. When it heated it's heated. Heated, mister, so T1 must be smaller than T2. So delta T is positive. Yeah, delta T is positive. So let's get the value of delta T here, delta T, and we need to get the value of Q. So, mister, we know that if we make a cross method here, so Q equals to CP times M times delta T. But we don't have CP. Yeah, we have CP. Look, we just calculate. Okay, so CP is 0.2. But what about M, mister? Where we get the value of M? Okay, look, we have 4 grams. So put 4 grams. But what if question said, how much energy will the same glass of sample gain if 8 grams of this sample heated from 340 Kelvin to 344, 8 grams, then you have to use 8. But because of it doesn't mention a new gram, so use the old one. Times 4 times and delta T. Okay, let's get the value of delta T between them. Delta T equals to 344 minus 340 equals to, I think it is, yeah, 30 Kelvin. So times 30 equals to, Q equals to 24 joule. Just like this. We are bringing it, we just take it out. We took out Q with CP here, then we use it for the B unknown, the unknown of B. I think it's very simple. It's very simple, please. Don't confuse. How we know our solution is correct? Look, when the sample heated by 40 Kelvin, it absorbs 32 joules. So when delta T equals to 40 Kelvin, Q was equal to 32 joule. But now, delta T equals to 30 Kelvin, Q, look, we heat it by 40, it absorbs 32. But now, if heated by 30, it must be absorbed smaller amount of this. Look, yeah, it's true. 24. I know the fast way, but I don't want to mention the fast way, the cross method between delta T and Q. If delta T equals to this, Q is this. Is delta T cross? No. Okay? So, stay far away from that kind of fast way. Same idea. Look, 4 grams of sample, it's M. 4 grams of sample was heated from 274 to, this is delta T, okay, and was found to have absorbed 50 joules. So immediately it's Q, get the value of Cp. As I told you, if you have these M, Q, delta T, immediately calculate Cp, then bring Cp for the unknown. Cp equals to Cp, Qm delta T, this is Cp. Then, how much energy will the same sample of glass gain when it heats from 300 to 500? So delta T this time equals to 200 kelvins. Calculate Q. Q equals to Cpm delta T. We have Cp, we have M, 5 grams, we have delta T. Same idea, I think. Same thing. Look, my dears, instead of gram, it's okay to use number of mole if there is no molar mass. But if you have molar mass, look, in a question, if we have, if M equals to gram or if M equals to mole, if you have molar mass, mole must be changed to gram, okay? If you have molar mass, gram must be changed to mole. But if there is no molar mass, use the known, use the given directly. If it's gram, it's okay. If it's mole, it's okay. But if you have molar mass, immediately change to the other unit. Just like this. Calculate Cp for indium matter, In, as a chemical symbol. Given that 1 mole, so it's M. Okay, where did it go? Please. Get back. Okay. Look, it's M. And absorbs 53 joules. It's Q. And these are delta T. It's okay. Just introduce the known, the given informations into a Cp equation formula. You can get the value of Cp simply. Cp, piece of cake, simply. I think it's the last question here. And the most difficult, but it's at the same time it's very easy. But comparing to the other questions, it's the most difficult because of it takes some further steps. Look, if 980 joules, it's Q, of energy are added to 6.2 liters of water, so it's M. At 298 Kelvin, it's T, but we don't know it's T1 or T2. What is the final temperature? So, because it asks us to get the value of Tf, so it must be T initial. T initial. We have T initial, and what will be T final of water? So we have Cp. Remember, if you have Cp in any question, you have to change all the units according to the unit of Cp. Because of, in the modern chemistry, actually we are studying modern chemistry, but we don't want to follow modern chemistry solving steps. Otherwise, it doesn't need to write any note. Look, we have Cp, so there will be cancelling in units. We cannot cancel kilojoule by joule. So we must change kilojoule to joule. And then M it's in gram, but it's in liter. There will not be cancelling, so we have to change liter into grams. So if you have CP, you have to change, you have to arrange, you have to manage all the units according to the unit of CP. هەموو یەکەکان بگۆڕە بۆ سەر یەکەی CP. Okay? شما بعد همه رو عوض کنید. ئەوە بە فارسیش پێم گوتی، بە سێ زمانە پێم گوتی. باشە بابی من؟ Kilojoule must be changed to joule. Look. First one, we have Q. Q equals to 980 joules. Kilojoule. So you must change into joule. How? Times by 1000. So Q equals to 980,000. Okay? 980,000 joules. It's Q. Okay. Then we have to change liter into gram. Mister, how we can change liter into gram? Such a huge trouble. No, it's not a trouble. Don't you remember the density? How we can make a relation between volume and gram? We have density. Look. Density equals to mass per volume. And there are two different units of where we have many, but I'm going to mention the most common one. So we have to, mass, if mass is in kilogram, so volume must be in liter. Another one, if mass in gram, it's possible to have mass in gram, volume must be in milliliter. So small with small, bigger one with bigger one, smaller one with smaller one. So we have to use this unit. We need to get the value of gram, but we must have milliliter. But look, we have liter. So we have to change liter into milliliter. Because of M equals to 6.2 liter, so we have to change into milliliter firstly. Into milliliter, right? So times by 1000 again. M equals to 6,200 milliliters. But still, we doesn't need milliliter. We have to change it into gram. But look, what is the value of D? Because of the sample is water. So you have to know density for water equals to 1 gram over milliliter. 1. But what if water changes to another substance? It must be given. Don't get this bad idea. Mister, 1 kilogram equals to 1 liter, so 1 milliliter equals to 1 gram. This is for water, but what if we have something else instead of water? So you're gonna be disabled. That's why D equals to 1. We are looking for gram, and milliliter is 6,200 milliliter, and now gram equals to 6,200 grams. Okay. We did nothing still. We are just made a conversion factors. Now write the formula of CP. Okay. CP equals to Q M delta T. We are looking for the final temperature, T final. So to get the value of T final, we need delta T, because delta T equals to T final minus T initial. We have T initial, okay? T initial is 298 minus, we don't have T final. So if we calculate T final, it's very easy immediately. T final, my God. T final equals to delta T plus T initial. So we must get the value of delta T. Let's introduce CP. CP equals to 418 equals to Q 980,000. M it's 6,200 times delta T. So delta T equals to, I think it's equal to 37.8. Let me check the result. Yeah, 37.8. 37.8 Kelvin. So now substitute delta T here. You can get the value of T final. T final equals to delta T is 37.8 plus T initial 298. So T final equals to, let me see, 328.8. 328.8 Kelvin. Just like this, you can solve the longest and at the same time the easiest question. Okay? So it was the last question in this part of chapter 4. Inshallah, I'll see you in a new lecture. Then I'll give you all the ideas and I will explain every single point about this chapter. Just don't be worried and don't, be a patient. Okay? Inshallah, you're going to get the highest mark. تاوكات بخواتان دسبيرم خواتان لەگەڵ.